Hi, welcome to day 37, aqueous reactions recap. Let's get started. Number one, decide if the following substances are acids, bases, salts. And if they are an acid or a base, are they strong or weak? All right, so let's recap. Acids, all right, H in front. Bases, they're metal hydroxides, right, and ammonia and its derivatives. Salts, ionic compounds, right? Ionic compounds. So now acids. When we talk about strong acids, there are 7 strong acids in this course. And what are those 7 strong acids? We got HCl, HBr, HI. So you got hydrochloric, hydrobromic, hydroiodic, right? The middle 3 halogens. Then you have H2SO4, sulfuric acid, nitric acid, HNO3, perchloric acid, and chloric acid. Those are your 7 strong acids. Every other acid is listed as weak. All right, so let's go to 1A, H2SO3. H is written out front, so acid. Is it a strong acid or is it a weak acid? Well, is it one of my 7 strong? Nope, weak acid. All right, so the next one, now there should be a subscript 3 there in case you don't have one. Aluminum nitrate. No H out in front, no hydroxide, metal, ionic, polyatomic ion, ionic compound, it's a salt. HNO3. All right, H out in front, acid, it's one of our 7 strong acid. HNO2. All right, H out in front, acid, not one of our 7 strong, weak acid. All right, this one, acetic acid. A lot of times it's going to be written as HC2H3O2 in your book. That is an acid, H out in front. However, not one of your 7 strong, so it is weak acid. H2SO4, H out in front. Sulfuric acid is one of your 7 strong acid. HClO2, chlorous acid. It's a acid, not one of our 7 strong, so it's weak. HCN, H out in front. All right, so we have hydrocyanic acid, not one of our 7 strongs. It is a weak acid. KClO4, potassium chlorate, not an acid, not a base, that's a salt. Sodium hydroxide, we have hydroxide, group 1 metal hydroxide, that's a strong base. NH3, that's ammonia, that's our weak base, right? Anytime we have nitrogen with its lone pair, it's going to be a base. And then last but not least, hydroxide, calcium hydroxide, group 2 metal, and hydroxide, that would be a strong base. And that is problem number 1. Problem number 2. We are going to list the detailed or complete and net ionic equations. All right, so let's check to make sure it's balanced. And one HCl, NaOH, NaCl, H2O, that's a balanced chemical equation, right? 1 sodium on both sides, 1 chloride on both sides, 2 H's and 1 O on both sides. All right, so we have to figure out, does HCl break apart? Well, it's a strong electrolyte. How do I know that? It's a strong acid. It's one of my 7 strong acids, strong electrolyte. It breaks apart right there. H plus Cl minus. Sodium hydroxide, does that break apart? Well, it is ionic and aqueous, strong base, breaks apart, Na plus OH minus. NaCl, does that break apart? Well, it's ionic and aqueous, so yes it does. Na plus Cl minus. Water, does that break apart? It's a liquid. No, it does not. All right, do I have any spectator ions? Spectator ions. Well, Cl exists on both sides, and so does sodium. So they are spectator ions, which leads us to the net ionic equation of H plus OH minus going to water. And there's A. B on this sheet is balanced, and it's also the complete and net ionic equation. So it's complete and the net. All right, that can happen. So on what I usually do in class, I don't know if you guys have this on your paper or not, I put HF down, so hydrofluoric acid, plus sodium bicarbonate, reacting to make sodium fluoride, plus carbon dioxide, plus water. And there we go. Now let's try this. Does HF break apart? Well, it's an acid, but it's a weak acid. Since it's a weak acid, it does not break apart. HF. Does sodium bicarbonate break apart? Well, it's ionic, aqueous. Yes, it does. And it breaks apart the cation and anion, right? Na plus HCO3 minus. Does sodium fluoride break apart? Well, it's ionic. It's aqueous, so yes, it does. Na plus and F minus. Does carbon dioxide break apart? Negative. It is a gas. What about water? Nope, it is a liquid. Do we have any spectator ions today? Let's see. Sodium. And that's it. So my net ionic equation would be hydrofluoric acid plus bicarbonate, yielding fluoride, carbon dioxide, and water. All right, C. And again, C, we usually write HC2H3O2 down for acetic acid and potassium acetate. Your book will have it written down O2. Excuse me. O2. There we go. And of course. All right. Does KOH break apart in solution? Well, it's a strong base, isn't it? Ionic and aqueous breaks apart right there. K plus OH minus. Acetic acid, does that break apart in solution? No, it does not. It's a weak acid. Does potassium acetate break apart in solution? The answer is yes. It is ionic and it is aqueous. Does water? No, it's a liquid. Any spectators? Potassium. And that's it. So our net ionic equation would be hydroxide plus acetic acid going to acetate. Oh, I forgot the minus sign, sorry. It's to H3O2 minus and water. And there is C. Now D, I usually do a different one because we've done this one in class. So I'm going to take that one out, and we are going to use this one where we have aluminum hydroxide. Now, I'm going to write down aqueous here. It may or may not be. It's not really. It's usually not aqueous. Well, let's do it that way then. Let's make it a solid. Plus 3 nitric acids, giving us aluminum nitrate and 3 waters. All right, does aluminum hydroxide break apart? No, it's a solid. So we get AlOH3 solid plus, does nitric acid break apart? Well, it's a strong acid, so yes, you get 3H plus, and you get 3NO3 minus. Right, it's very important to remember that this 3 goes to the H, and this 3 goes to the nitrate. All right, that's very, very important. Does aluminum nitrate break apart? Of course it does. Ionic and aqueous. And does water break apart? Of course not. It's water, it's a liquid. Spectators, spectators, spectators. I have nitrate is my spectator ion. So my net equation would be aluminum hydroxide plus 3 H pluses, giving me aluminum ion and 3 waters. And that is questions 1 and 2, day 37.